Hi, this is Roger Unger, and I'm the CEO of Dilus Corporation. And what I have here is the very first prototype, call it the alpha prototype, of what we're hoping we can develop into an ultrasonic visual assistant. Something that will help visually impaired people be able to navigate, through their homes or through their environments, with the assistance of a sonar-like detector. The basic idea behind this is that the brain already has a tremendous ability to 3D locate sound. And we do it all the time. We know whether a noise is coming to the left of us, to the right of us. The brain has the ability to process audio signals and to pull out location information from that. And it doesn't seem to us that anybody has really tried to do this in the way that we are trying to do it. What we want to do is we want to send out a signal like a bat, kind of like sonar, but then when the signal is converted into the audio spectrum, that the natural ability of the body to 3D locate will be enhanced by the signal processing that we perform on those returned ultrasonic reflections. So basically, this is just a very, very early version of it. It's an ultrasonic visual assistant, UVA, or we just call it the Ultra. And I think the best way to show you, what we're trying to achieve is to go out and demonstrate this. And I'll just walk around the home, I'll approach various obstructions or obstacles, and you can see how it functions. Now, at this point in time, I have only a very, very weak ultrasonic transducer on here. So it is not going to, the distance range on this is about 4 feet right now. That's clearly not acceptable. That can be fixed easily by increasing the power of the transducer. But to do all of this work, we need to change the amplifiers. We need to put this in some other form than this, make it an actual product. And all of that effort requires a lot of money, and it doesn't look like there's actually that much of a market for it. So what we want to do, what we're asking people to do, is to support us in this effort, because we're trying to do something good. We're trying to help people, adults and children who are blind, be able to cope with their environment better than they can at this moment. So having said all of that, I'll demonstrate it, and you can see some of the capabilities at a very basic level, some of the capabilities, and try to use your imagination about how much better this can work once we put in the enhancements that we hope to be able to do. All right, thank you. All right, so I want to start out here with, we're just pointing the Ultra out into more or less open space. There's nothing within 4 feet of us right now, so you don't actually hear any echo. You hear the initial pulse going out and some of the internal reflections, immediately around the transducer, but you don't hear any actual reflections from in front of us. And the noise that you hear in the background, that is part of the signal processing that we have put in, and we need to improve that. So let's kind of walk forward here, and you see we're still far away from everything, and you don't hear any reflection. But let's see what it sounds like. Let's come over here so you can hear what a reflection is going to sound like. There. You hear that at the very end, that boom. And it's getting louder as we get closer. Okay, there we go. back off here, and you can see where we about reached the level of detection. We're starting to get towards the end of it. There. And that is about 4 feet, and that's as far as we have as much memory and processing time and so forth in order to be able to do. Now you can hear, this is a good point, because you can hear a little reflection, and if you listen very, very carefully, you can see it's to the left, and that is this chest here. Okay, so let's move here, let's move through. Okay, now there's nothing because we're in open space. Still nothing. Now you start to hear things, and this is the chair to the left of us here, and it's this cabinet here to the right. So let's keep going. And basically you're not hearing anything now because that wall is more than 4 feet away from us. So let's approach it and see what happens. There, you can hear it now. It's getting louder. Getting a lot louder. So that's a wall. That's a large surface. Now let's compare that to this chest here. Now, if you listen very carefully, you can kind of hear why we're a little bit enthusiastic about the capabilities here, because here we have a chest, but it's not just a flat surface, it's a flat surface, and then inside you have a lot of objects. And if you listen to it, you can hear that the reflection is a bit more complex. Okay, let's go back over here. Back over here. Hear that? It's kind of more extended in time, and what I think that is that's the ultrasound going through inside the cabinet and then reflecting off the objects inside the cabinet. So I think if somebody gets really attuned to this, you're going to be able to hear, oh, I've got an obstruction in front of me, but then there's even something beyond that. Now let's go back, let's go out into this hallway. And you see it's pretty dead right now because there's nothing really, except for these walls to the sides of it, there's nothing within 4 feet in front of us. So let's go. It's very dead there because we just went into a more open area. Let me back up. I think you can hear some reflections there. And here it kind of goes dead. So let's keep walking. We shouldn't be hearing much of anything until we come up to this chest. Or we point to this wall. There you hear it. Okay. Just to compare, look at the wall. And then dead. Now let's go down the hall here. Okay, now we're going to go on to another kind of object here. This is obviously a large object. It's not a flat wall, and it's soft. So we would expect that it is going to reflect sound differently than those other objects. And you can hear a difference. Okay, let's see over here. Now this is another example of what I would call a complex environment and a complex reflection, because it's not just a single pulse back. You're hearing multiple pulses. I mean, I think if you get good at this, you could maybe hear 6 kind of distinct reflections off there. Okay, let's see if there's a difference here, and I haven't tried this, but okay, here we have let's go down here. Here's a solid wall, and we're straight on. We're about 1.5 feet from it. And now let's go to the right to a window and see if that's different. That is very interesting. Maybe it's the blind that's in front of this window, but it's a much softer reflection. So you hear that difference? And I'll back up so you can see what we were doing there. Okay, so there's that window, and then there's that wall there. So let's go around here. Now, if you listen down the hallway, there's only slight reflections coming from the sides, right? But mostly it's open. The main amount of energy is radiating forward and it's not being reflected back. Or it's taking so long to come back because we only have about 4 feet of range on this. But you can hear that, although you're not hearing the reflection, that kind of hissing that you're hearing, what that really is that is noise, and that's really all that is, and that's a product of the fact that we haven't gone through all of the engineering to get these the microphones that we're using to optimize them for the frequencies that we're at and so forth, and we can also signal process and analog process a lot of that out. So that's just time and effort to try and do that, and that's something that we feel that we very much can do. Just to give you a little more information, we're using a very simple ultrasonic transducer to transmit, and then we're using what are called MEMS microphones to receive the ultrasonic signals. And the reason we selected those is because those have a very broad bandwidth. And so we want to be able to hear the different frequencies coming back so that we can give that information to the brain. We can audio process that and give that information to the brain so the brain can have a better idea of how it's going to 3D locate. So let's just see if I can try anything else here. I don't know if you can hear that kind of sounds like it's coming from the right or not. We need to work on that. Some of that is just the timing considerations that we have for the signals. We have to precisely place these MEMS microphones to get the proper left-right delay, and we haven't done that. Deadness right there. Okay, so this is just a brief demonstration of what we have, and obviously there's some potential here. There's a lot of work that still has to be done, and we need financial support to be able to continue and do this work, because it doesn't look like there's the market out there that's going to justify the amount of engineering that we're going to have to put in here. And we will, talk about this some more, explain this in more detail. But if you want to do something good, if you want to help this world, make this world a better place, we would appreciate your financial assistance. And thank you very much.